Day, everyone. My name is Dr. Oluwafemi George from the Department of Systems Engineering, University of Lagos. Today, I'll be continuing our lecture on operational methods 1. In our introductory lecture, we defined a periodic function as a function that repeats itself at regular intervals. In that lecture, we also gave expressions for estimating the average and root mean square of a function. As a quick recap, we can say from the graph, this graph, that function f of x repeats at every period p. We defined f of x as f of x plus np for n equals plus or minus 1, plus or minus 2, plus or minus 3, and so on, taking care of both the positive and negative x-axis movements. Also, we have expressed the average and root mean square of a function f of x over an interval a comma b as y bar equals 1 over b minus a, the integral from a to b y dx, and y bar equals the square root integral of a to b y squared dx over b minus a. If you haven't seen that video, here is the link to the lecture. Today, we are going to extend our understanding and definition of periodic function. A function is periodic of period p and frequency omega equals 2 pi over p if and only if f of x plus np equals f of x, where n equals plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, and so on. This condition is satisfied in both the positive and negative x-axis, and the average of a periodic function is given by y bar equals 1 over p, the integral from 0 to p f of x dx, which is equal to 1 over np, the integral from a to a plus np f of x dx, where a is any number and n is an integer greater than or equal to 1. To aid our understanding, let us consider some solved examples on periodic function. 1. If f of x is equal to x squared in the interval 0 less than x less than 1 and f of x is equal to 2 minus x in the interval 1 less than x less than 2. Sketch the graph of y equals f of x for minus 6 less than x less than 6 if a f of x is periodic of period 2, b f of x is an even function and periodic of period 4, c f of x is an odd function and periodic of period 4. Now, to the solution. Example 1 says we should sketch the graph of y equals f of x for minus 6 less than x less than 6 if f of x is periodic of period 2, even and periodic of period 4, and finally an odd function and periodic of period 4. But before we provide the sketches required, we begin by sketching the basic given function. And to do that, we will construct a table for f of x equal to x squared and f of x equals to 2 minus x in the interval of -6 less than x and x less than 6. So let's do that quickly. So we have x, then we have f of x equals x squared. Then we also have f of x equals 2 minus x. So we have the interval of s moving from -6 to +6. So we have -6, we have -5, we have -4, we have -3, we have -2, we have -1, we have 0, we have 1, 2, 3, 4, 5, and 6. So for f of x equals x squared, we have 36 for the first one. We have -5 squared for the second one, which gives us 25. So for this first one, we have -6 squared, it gives us 36. So for this one, we have -4 squared, and this gives us 16. We have -3 squared, and this gives us 9. We have -2 squared, and this gives us 4. We have -1 squared, and this gives us 1. We have 0 squared, which is 1 also. I mean 0 rather. 0 squared is 0. We have 1 squared, which is 1. We have 2 squared, which is 4. We have 3 squared, which is 9. We have 4 squared, which is 16. We have 5 squared, which is 25. We have 6 squared, which is 36. Then we do the same thing for f of x equals 2 minus x. So for -6, we have 2 minus -6, which is 8. For -5, we have 2 minus -5, which is 7. For the next one, we have 2 minus -4, which gives us 6. For -3, we have 2 minus -3, which is 5. For minus 2, we have 2 minus minus 2, it gives us 4. For minus 1, we have 2 minus minus 1, which gives us 3. For 0, we have 2 minus 0, which gives us 2. Now, for 1, we have 2 minus 1, which gives us 1. For 2, we have 2 minus 2, which gives us 0. For 3, we have 2 minus 3, which gives us minus 1. For 4, we have 2 minus 4, and this gives us minus 2. For 5, we have 2 minus 5, which gives us minus 3. And finally, for 6, we have 2 minus 6, which gives us minus 4. Now, we have all the values for f of x equals x squared and f of x equals 2 minus x in the interval minus 6 less than x and x less than 6. So if we combine the two functions, we have a range of interval of 0 less than x less than 2, since f of x equals x squared is in the interval of 0 less than x less than 1, and f of x equals 2 minus x is in the interval of 1 less than x and x less than 2. So given this, with this, the basic given function, if you want to sketch the function, so the function for this is something like this. So let's have the function. We have the function as this. This is somehow curved. Then we have this, which is like a straight line. So this from here like this is 1. This covers the first one, which is f of x equals x squared, and this is 2. So this function is f of x equals x squared, and this function is f of x equals 2 minus x. So the question says f of x is periodic of period 2. We have to sketch f of x is periodic of period 2. So the period is 0. So if we are to sketch the first one, which we say is A for f of x, which is periodic of period 2. So we have something that looks like this. We have something that looks like this. So for period 2, let's say this is the middle. Then we have something that looks this way. So we know that this is 0. and this is 2. This point is 2, and this point is 4, and this point is 6. So to the left also, we have something that looks like this. It should be noted that this figure is not drawn to scale. And finally, we have this. So this is -6, this is -4, and this is -2. So we can decide to put this dash at the middle. This will be our -5. Also here, this will be our -3. Here also, this will be our -1. Please pardon me, this is not drawn to scale. The same thing on this side. This is 1, this is 2, 3 rather, and this is 5. So we've been able to draw for A. Now, the second question says, if f of x is an even function and periodic of period 4. Let us note that, like we said before, f of x equals x squared is quadratic, while f of x equals 2 minus x is linear. And from these functions, we can say that f of x equals x squared is an even function, while f of x equals 2 minus x is neither even nor odd. So now the second question says that if f of x is an even function and periodic of period 4. So to check if f of x is even, we can simply say for an even function, we know that f of x is equal to minus, for an even function, f of x is equal to f of x minus x is equal to f of x f of minus x. So we say this is even. And for an odd function, we say minus f of x is equal to f of minus x. So this is for odd function. So I think this is not coming up. So let me write it. Okay, it has come up. So for an odd function, minus f of x is equal to f of minus x. So the second question says that you sketch for f of x is even and periodic of period 4. So we have established that f of x is even and f of x equals 2 minus x is neither even nor odd. But we know the basic function, even function. So for here, to generate even function, we know that we have the curve on the right. So we also need to plot another similar periodic function on the left for which it is periodic and of period 4. So the given function, the given function is something that looks like this. So now I'm trying to plot the function for which f of x is even and periodic of period 4. So so it looks something like this. Let's say this is the central. This is the central. And this center we say is our y. The vertical line is y. And this is x axis. This is x axis. So now you can plot this function like this. This, say this is 6 and this is 2. This is not really drawn to scale. This is -2. And finally we have this. So this is -6 and this is -2. Then we have 0 here. So in a way, we have the function which is even with p equals to 4. Now, this is the second solution. Is solution to the second question of example number 1. So finally, we are to consider a case where f of x is odd and periodic of period 4. So like I said before, neither f of x equals x squared nor f of x equals 2 minus x is odd. Neither is odd, but we know the basic function. So to generate the odd function, we plot on the negative side of x, and on the negative y-axis, we replicate the basic given function on the negative side of x, and on the negative y-axis, while keeping the original plot, the given function. So this is the function that we have. This is the basic given function. So we have this as the basic given function. So to replicate that on the negative x and the negative x-axis, y-axis, we have something that looks like this. We have something that looks like this. So this is the first one. Then again, note that this is 0 and this is minus 2. This is minus 2 and this is 2. Taking care of the period, which is 4. Then we can generate another plot that looks like this. So let's take it from here. So we have minus 6 here, and we have another plot to add here. So this one can go like this first. So to complete this, we have something that looks like this. And this is 6. So we have been able to complete this plot. So this is a plot for odd with p equals to 4. Of course, we say this is odd. That is when f of x or f of minus x is equal to minus f of x. And that's comes to the end of example 1.